Hello and welcome to the Innovation TRIZ webinar. First, information about Ariadne. We are a consulting company and we help our customers to use the digital information to build high quality products. We want to help you to be more competitive. In the picture down to the right, you can find our competences. The source is the CAD model, and if we have all of the information digitally in the CAD model, we can use it in many other areas. For example, it's very easy and fast to do a tolerance analysis. One of our main focus is model-based definition and how to work fully digitally. And use the digital information downstream, and it will benefit all of your organization, work faster and with less errors. Our business area is software consulting and training. We PTC with CAD software, Sigmetrics with tolerance analysis, Capvidia automatic inspection. Anarch is intelligent information management. We have a webinar of this in our YouTube channel. Training, we do model-based definition workshop, tolerance analysis, GPS coaching, and much more. You can find more information on our homepage. Training, TRIZ, the focus of today, GPS, MBD workshop and additive manufacturing, and much more there as well, and find more information on our homepage. We talked about TRIZ training, and we can call it a workshop. We are doing workshop for you on site, and it's a great training to get you more creative and find new solutions to all issues. We also do open trainings here in Västerås. Now it's time for you, Michel, and talk a little bit more about innovation.
Oh, yes. Thank you very much. If you could stop your presentation, then I will do mine. Yes, I hope you are seeing the candle. Yes.
Yes, great.
We are talking about innovation, not only very small improvements, but also the radical innovation, and TRIZ is very good at it. How it works? Usually the brain is limited with finding solutions because innovation really is solving problems. Yes, when we solve problems, then we get innovation. So this soldier who is knocking at the door, kicking the door, he's not stupid, he's just experienced. 5 doors before he opened with kicking, and now he cannot do it because his focus is narrowed. Yes, and TRIZ is much better in bringing new ideas, new solutions to our view. Let's start from where it is. If somebody is not using any method, then the innovation is by trial and error. This is quite a good method because finally you have to try your solution, but there are some better ways. Usually people are at the second stage, which is brainstorming, which is collecting as many ideas and then choosing one or maybe 2, 3 ideas, best ideas to proceed further, doing some trials with it. But still, it is limited. Yes, sometimes you find competition found a better solution, and we were looking at the same problem. We couldn't find this solution, and they patented, etc. Maybe they are using TRIZ. TRIZ is systematic and is more effective in finding solutions, but brainstorming is easier to learn. it is that you have to learn those methods, those tools TRIZ is rich with to reap the full benefit of many and really better ideas many times. The story of TRIZ, usually people learn that it was started by Henrik Altschuler in former USSR, which is true. He did enormous job with some workers, and it was not known until about 20 years ago when Samsung used TRIZ to take over Apple. Here you can see a comparison between a part of Samsung, which is Samsung Electronics, and Sony. Sony is doing quite all right, but Samsung is doing far better. If you look at the numbers, one of the main reason is using TRIZ. This you can find out in articles about the history of this, how Samsung became a very innovative company, because you can learn how to be innovative. Yes, if you are at certain level of innovation, you can improve, and this is a great work of Altschuler, who showed that yes, you can learn to be more innovative. So after Samsung, many other Korean companies took on with TRIZ, like Hyundai or LG, maybe you know, Kia or POSCO. They all use TRIZ for their solving their problems and patenting, if you are interested in patents. So I collected a few examples of using TRIZ, and first a few will be connected with one of the tools from TRIZ, which is 40 principles. Usually when people hear about TRIZ, they think about 40 principles, but this is only one tool. There are far more tools in TRIZ, but still it is quite easy to use. And if you look, for example, at number 15, dynamics, it says you can move something to each other. Things are movable, and you will see this in next example. So this is only one tool. Yes, this, like 40 principles, there are over 30 tools like this one. This is one tool. Central in TRIZ is the finding that problems are difficult because there are contradictions inside the problem. For example, if we have a keyboard, a computer keyboard, then we want this keyboard to be quite large because our fingers are not very small. So it is easy to write on a keyboard which is larger. But a large keyboard has another problem. If we have very, very small bug, then we cannot get the keyboard inside. So watch the solution by LG. I have some example of this keyboard with me, yes, and it is the dynamization. It is the number of principle 15, I told you, yes, they used to make this rolling keyboard, which is very small for transportation and very easy to make it big. It connects via Bluetooth with your smartphone for writing, yes. So central in solving problems is the finding that problems are difficult because of contradiction. And here we have another example of Xerox, where they had this instrument, this machine to fill the container with toner, and the machine was not very fast. They wanted it to be at least 30% faster than the previous machine. But when they started to turn with higher rotation, this Archimedes screw, which is working downwards, they found out that it creates a new problem. The toner is stopping. Yes, from time to time it is not flowing, and you never know where it stops flowing. So they were not happy with this solution. They were looking for other solutions. So I interviewed Oleg Abramov, who was project manager of this particular solution. Yes, you can see it's finished with a patent. Who said it only took one afternoon to find the idea. To refine the idea, it took them 3 months to make it the prototype to work very, very fast, because they were paid for the speed of the machine. As you see, they resigned from the rotating Archimedes screw. They replaced it with vibrations, yes, or oscillation, which is the principle number 18 from 40 principles. And they started from the speed 100%, and they finished with 1,900% of the speed of this solution. Of course, vibrations are known idea, but you usually don't think about using it into this particular situation, as they thought about the situation and they couldn't find this idea. After small inspiration from TRIZ, they of course found how to make it in this particular situation. This is just illustration. Of course, the dogs are not knowing TRIZ, but this is a nice illustration how you have the neck cover, which is not very nice for the dog, and you can use it for something good. But I remember we had a guest on Technovation Forum, a conference some time ago, who came from Rolls-Royce. This Rolls-Royce making not the cars, but making the airplane engines. And he was for 20 years, he was R&D global director, and he said how he first learned about TRIZ, and it was this particular principle, number 22, they used to solve the problems created by fast rotating gases in the turbo ventilator engine. And he said they had several ideas just from this one principle. 2 out of those ideas they patented, and one of the patents won the award. They have once a year an award for best patent, the highest value patent in Rolls-Royce. So with this, he took all his engineers to go through the TRIZ trainings, because they are very in need of innovation in this industry. This is some other example from a maritime sector. You can see the aft part of this thug, and there are 2 thrusters on yellow. Yes, you can see now they are better seen. There are electromotors powering those thrusters, and the problem they found was on the very end of the making the design of this thug, which was later built in Japanese shipyard. The problem was that they learned too late what are the dimensions of the electromotor. They assumed it was narrower, but later they found out it is not so narrow, and the minimum distance for person to go through is 700 millimeters. Yes, 612 is too little. They have to make it wider to comply to go with the certification. Yes, so they have to find an idea, but there is no no solution except do the design again, which is something like 750 engineering hours to do it, which they don't want. Yes, they paid already, and they don't have time to to do it again, because there is only 2 weeks and have to give back the documentation to the customer. So we used TRIZ, and we found out what is the contradiction. And one of the principles said what things you can join together to get a new situation. So we were thinking about this, and one of the engineers, took him a few minutes, was thinking just with this idea, what can I join together to get new quality. And in a few minutes he came to rest of us with an idea which later was chosen as a solution. So the thug is somewhere on the ocean right now with this solution. As you can see, those frames are welded together with additional steel, and they have the right dimension they needed. So this, for them, even very experienced engineers in this sector of industry, they couldn't find this idea. Later you can say, okay, it was easy, but for them to get this idea was not so easy. And this was about 40 principles. And now another TRIZ tool, which is called ideal result, which is really to grasp it intellectually, it is easy, but to use it later, it is difficult because it is completely out of what are our habits. Yes, our habits, everybody in every country, is to improve the solution. We have some solution which is not good enough, and we try to improve it. To start thinking from the other side, from the top right side, with the ideal system, we have to imagine that there is an ideal system, and how we can get it. Sometimes we have to step back, or 2 steps from this ideal system, but still it is far better idea starting from this part than from the bottom part. If we run from the bottom, it is very, very time consuming. And if there are several solutions, which is often the case, we don't see any solutions in the beginning, but later we can find out that there was more than one solution. When we look for solutions from the bottom, we usually get the worst solution from any solutions, and we are happy with it. We go with this solution. But if we would go from the ideal system, then we would work far less. We would get the result sooner, and the quality of the solution is far better from the other side. This is the statistics. One more, or maybe 2 more examples. This one was using the inspiration by the TRIZ tools called what resources you have. And the story starts with production facilities in 2 countries in Southeast Asia, in China and in Thailand. They were producing those shoes. It was a few years ago. And there were thieves who were stealing quite a number of those expensive shoes right in the factory, or between the factory and the ship, on the transport, yes, from the factory to the port. So the company took normal measures against the thieves, anything you can imagine, and they were applying those things. First, there are cheap solutions, then you try some more sophisticated, more expensive solutions, but still the thieves were quite inventive. Yes, they were creative in their ways to steal those expensive shoes. So the company finally took TRIZ to get the idea, and they found a very simple idea, which they finally decided to it. The solution was to do only the left shoes in China and right shoes in Thailand, and they were completed back in the United States, which costed the company only a few cents prepare for the completion, yes, that you have left and right shoes together. So as you can see, there are many ideas which don't easily come to mind at first, and sometimes you spend a lot of time kicking the door like the soldier in the beginning to find out that there was a better solution. I can see that I have some more time to show you another example of TRIZ. It is historical example from Procter & Gamble, a US company, which targeted the market of people who wanted to have the teeth white. Yes, and this is the old solution which was used before, that you had some peroxide inside the tray, and then for the whole night you had to put it on your teeth, which was very uncomfortable. And they asked for help, people who knew the TRIZ very well. And with help of the TRIZ, the engineers plus the Procter & Gamble engineers, the R&D people, they used a TRIZ tool called function-oriented search. They were looking for other solutions in different industries, and they found anti-smoking patches to be a good inspiration, and from this they came to the white strips, and the outcome was that with the white strips, in the first year they took most of the market, or nearly half of the market. So possibly you have seen this solution. It didn't change for last maybe 2 decades when it was first done. And a final example is cheaper bottle. It is also the US example. The manufacturer of plastic bottles. Yes, you in Sweden usually have glass bottles, but some parts of the world still have plastic bottles. This company wanted to cut the cost. The main cost is transportation, and other main cost is the bottle. Yes, the transparent part is PET, which is quite expensive. So the solution also came with function-oriented search. I will just jump to the solution, and they started to add a little of liquid nitrogen just before closing the bottle. So the bottle is with not carbonated. Yes, there is no fuzzles, no gas, but nitrogen is here to making pressure, so it is stronger, and then it is not broken during transportation with weaker when they added less plastic. Yes, so it saved them quite amount of money, and it is used in many other countries because it was patented only on US, so others took this patent for granted in other countries. I can open this. Maybe you can hear a little of nitrogen. There was very little psst, and that's it. So it is not sparkling water, but the bottle was very hard. Now it is weaker. So during transportation without this gas, it could be damaged. With the nitrogen, you cannot damage it. So I'm happy I finished what I prepared for this short presentation, and I return to Patrick. Hello, Patrick.
Hello, and thank you very much. I will tell you a little bit